two 8-bit blocks, using SM4 encryption, JOX in CPUs only. Virtualization instructions. AMDV instructions. Instruction meaning not subcode equal clear global interrupt flag clears the GIF 0x0F0x010 cst invoke gain validate TLB entry in R specified ASID invalidates the TLB mapping for the virtual page specified in RAs and the ASID specified in ECX.0x0F0x010 cst skinit secure init and jump with attestation verifiable startup of trusted software based on secure hash comparison 0x0F0x010 discharge a global interrupt flag sets the GIF.0x0F0x010 from load state from VMCB loads a subset of processor state from the VMCB. Specified by the physical address in the racks register. 0x0F0x010 Stavum call VMM used exclusively to communicate with VMM 0x0F0x010 XD9 run virtual machine performs a switch to the guest OS. 0x0F0x010 XD8 VMSAVE save state to VMCB saves additional guest state to VMCB. 0x0F0x010 XDB. Intel VTX instructions. Instruction meaning not subcoding VEPT invalidate translations derived from EPT invalidates EPT derived entries in the TLBs and paging structure caches. 0x66 0x0F0x38 0x80 INVVPID invalidate translations based on VPID invalidates entries in the TLBs and paging structure caches based on VIP. 0x66 0x0F0x38 0x80 VMFUNC invoke VM function specified in EAX.0x0F0x010 XD4 VMPTRLD load pointer to virtual machine control structure loads the current VMCS pointer from memory. 0x0F0xC7/6 VMPTRST store. Pointer to virtual machine control structure stores the current VMCS pointer into a specified memory address. The operand of this instruction is always 64 bits and is always in memory. 0x0F0xC7/7 VMCLEAR clear virtual machine control structure writes any cached data to the VMCS. 0x66 0x0F0xC7/6 VMREAD read field from virtual machine control structure reads out a field in the VMCS. 0x0F0x78 VMWRITE write field to virtual machine control structure modifies a field in the VMCS. 0x0F0x79 VMCALL call to VM monitor calls VM monitor function from guest system. 0x0F0x010 XC1 VMLAUNCH launch virtual machine managed by current VMCS. 0x0F0x010 XC2 VMRESUME resume virtual machine managed by current VMCS. 0x0F0x010 XC3 VMXOFF leave VMX operation stops hardware supported virtualization environment. 0x0F0x010 XC4 VMXO enter VMX operation enters hardware supported virtualization environment. 0xF3 0x0F0 XC7/6 undocumented instructions. Undocumented X86 instructions. The X86 CPUs contain undocumented instructions which are implemented on the chips but not listed in some official documents. They can be found in various sources across the internet, such as Ralph Brown's interrupt list and at sunpile.org. Some of these instructions are widely available across many /most X86 CPUs. while others are specific to a narrow range of purpose. Undocumented instructions that are widely available across many x86 CPUs include mnemonics opcodis description state use animate D4 imate ASCII adjust after multiply. Convert binary multiplication result to BCD. Available beginning with 8086. Documented since Pentium. Earlier documentation lists and arguments. AAD imate D5 imate ASCII adjust before division. Convert ABCD value to binary for a following division instruction. Division counterpart of ARM available beginning with 8086. Documented since Pentium. Earlier documentation lists and arguments. SALC set ALC 6 set L depending on the value of the carry flag. A 1-byte alternative of SBBL, AL, available beginning with 8086, but only documented since Pentium Pro. Test 6/1 F7/1 undocumented variants of the TEST instruction. 65 performs the same operation as the documented F6/0 and F7/0 variants, respectively. Available since the 8086, 80186 for the C0C1 variant of SHL/SAL. Unavailable on some 80486 steppings. 66, 67, SHL SAL, D0D3/6, C0C1/6 undocumented variants of the SHL instruction. 65 performs the same operation as the documented D0D3/4 and C0C1/4 variants, respectively. Multiple 82/07 imate undocumented alias of opcode 8068, which provides variants of 8-bit integer instructions, add or ADC SBB and sub X or CMP, with an 8-bit immediate argument. Available since the 8086. Explicitly unavailable in 64-bit mode. Repens moves repens stas2, A4 A5, F2, AAAB. The behavior of the F2 prefix, repens rep, when used with string instructions other than CMPS/SK is undocumented, but there exists commercial software, for example the version of FDISK distributed with MS-DOS versions 3.30 to 6.22, 69, that rely on it to behave in the same way as the documented F3, rep, prefix. Available since the 8086. Rep3C3. The use of the rep prefix with the AIT instruction is not listed as supported in either the Intel SDM or the AMD APM. However, AMD's optimization guide for the AMD K8 describes the F3C3 encoding as a way to encode a 2-byte AIT instruction. This is the recommended workaround for an issue in the AMD K8's branch predictor that can cause branch prediction to fail for some 1 byte. AIT instructions. 70. At least some versions of are known to use this encoding. 71. Executes as RET on all known x86 CPUs. ISEP.1F1 single byte single step exception /invoke easy available beginning with 80386. Documented as INT1 since Pentium Pro NOPR/M0F1F/0 official long NOP. Introduced in the Pentium Pro in 1995. But remained undocumented until March 2006. 30, 72, 73, available on Pentium Pro and AMD K7, 74, and later. Unavailable on AMD K6, AMD Giadel X via Nehemiah. 75, NOPR/M0F0D/R reserved. NOP. Introduced in 65 nm Pentium 4. Intel documentation lists THIS opcode as NOP in opcode tables but not instruction listings since June 2005. 76, 77, available on Intel since 65 nm Pentium 4. from Broadwell onwards, 0F0D/1 has been documented as prefetched on AMD CPUs. 0F0D with Amory argument is documented as prefetch/prefetch K6-2, originally as part of 3 GNO, but has been kept in later AMD CPUs even after the rest of 3 GNO was dropped. UD1UD00FB9,0FFF intentionally undefined instructions. Like UD2, these instructions were left unpublished until December 2016. 78-79 Microsoft Windows 95 setup is known to depend on 0FFFB engine valid. 80-81 It is used as a self-check to test that its #UD exception handler is working properly. Other invalid opcodes that are being relied on by commercial software to produce #UD exceptions include FFFF, diff2, 82, laser lock, 83, and C4C4, BOP, 84, 85. However, as of January 2022 they are not published as intentionally invalid opcodes. All of these opcodes produce #UD exceptions on 80186 and later, except on NEC v20/v30, which assign at least 0FFF TOTHCOM instruction. Undocumented instructions that appear only in a limited subset of X86 CPUs include mnemonics opcodes description status avial storial 0F04 exact purpose unknown, causes CPU hang, HCF. The only way out is CPU set. 86, in some implementations emulated through BIOS as a halting sequence. 87, in a forum post at the Vintage Computing Federation, this instruction is explained as Savial. It interacts with ICMode. Only available on 80286 Loadal 0F05 loads all registers from memory address 0x000800. Only available on 80286. Opcode reused for SYSCALL in AMD K6-2 and later CPUs. Loadal 0F07 loads all registers from memory address SEDI only available on 80386. Opcode reused for SYSRET in AMD K6-2 and later CPUs. CL1 Invum 0F088, on the Intel SCC, single chip cloud computer, invalidate all message buffers. The mnemonic and operation of instruction, but not its opcode, are described in Intel's SCC architecture specification. 89, available on the SCC only. Patch 20F0E on AMD K6 and later maps to FEMM's operation, fast clear of MMX state. Boot on Intel identified as watch data read on Intel, 90, only available in read unlock state, 0F0F2. Patch 30F0F write watch can change RAM part of microcode on Intel UMOVR/MUMOVR/MR0F 1013/R moves data to / from user memory when operating in ICE halt mode. 91 acts as regular MOV otherwise. Available on some 386 and 486 processors only. Opcodes reused for SSE instructions in later CPUs. SCALR/M0F18/0 superstate call. 92, available on Chips and Technologies Super 386 CPUs only. XOP 0F55 Next Gen Hypercode Interface. 93, available on Next Gen NX586 only, multiple, 0F, E0FB, 94, Next Gen NX586 Hypermode instructions. The Next Gen NX586 CPU uses hypercode, 95. X86 code schemes is unpacked at boot time and only accessible in our special hypermode operation available in NX586. Hypermode only. Mode, similar to December Alpha SPAL code, for many complicated operations that are implemented with microcode in most other X86 CPUs. The X86 provides a large number of undocumented instructions to assist hypermode operation. Swap mm/m640f0f/RBB undocumented AMD3D now. Instruction K6-2 and K6-3. Swaps 16-bit words within 64-bit MMX register. 9659. Instruction known to be recognized by MASM 6.13 and 6.14. Available on K6-2 and K6-3 only. Opcode reused for documented PSWAPD instruction from AMD K7 onwards. Unknown mnemonic 64D6 using the 64H FS segment prefix with undocumented D6 SALC /set ALC. Instruction will, on UMC CPUs only, cause EAX to be set to 0xAB6B1B07.5397, available on the UMC Green CPU only. Executes as SALC on non-amicpus.fs, JCC 6477F, RIL 8,640F, 88F, RIL 16/32 on Intel NetBurst. Pentium 4, CPUs the 64H, FS, segment. Instruction prefix will, when used with conditional branch instructions, act as a branch hint to indicate that the branch will be alternating between taken and not taken. 98. Unlike other NetBurst branch hints, CS, unlike other NetBurst branch. Unknown mnemonic 0FA7, C1C7. Detected by CPU fuzzing tools such as SoundSifter 102 and UIS Fuzz 103. ACE executing without cause.
Yes, I did click by mistake. But we have the video splits in 2 minutes, but we are out of power. I think we have to finish. I think I have to charging my camcorder a bit. Now the weather is nice. Let's drink some cola. Of course, I not remember this. Of course not. But I like to see this X86 instructions. But how you use these instructions, I don't know. But now I know there's a lot of X86 instructions for the CPUs. But this is real computer science, that's for computer programmers. Now the weather is super nice. So that's a lot of science, not only microelectronics, but also software science into computers. That's just the PC, that's the personal computers. Then you have software for supercomputers. They use all other kind of CPUs, I think. And this science just go on and on. Every year they're getting clever and clever. But we are out of power. I like to, that's 6 parts. This other part is ready, so I will start to upload this 6 parts.